Hi and welcome to video 4 on how we might collect data and display data in the frequency tables. Okay, so let's just talk quickly about how we collect data. You'll see from previously in the video, I've got my 4 categories of data here: numerical discrete, numerical continuous, categorical ordinal and categorical nominal. I'm going to start over here with the categorical ordinal and nominal and how we collect data, and you'll recognise the term frequency table. That's what we're going to be mostly talking about. In your earlier years, maybe a tally chart would have been more correct, and it's the principles there with that tally chart idea. So let's say we're collecting data on shirt size. Shirt size is going to be a categorical ordinal, but I'm going to just match it up with the nominal as well. So if we're doing eye colour or whatever, we get the same type of frequency table here, but just a couple of pieces of language that you need to know. So if we're talking about shirt size, then I would obviously have a category called shirt size, and then I would have frequency and percentage frequency. And if I had better space, maybe I would actually write those words out. So my shirt sizes I might have as extra small, small, medium, large, extra large, and maybe in this case you've got an extra large, okay? Whatever it is that you need. And you've gone around and you've collected information about what shirt sizes certain people at your business need, for example, and you've put this into a tally because you need to go and buy some shirts. So let's say you've worked out that one person needs an extra small, but 5 people need a small, and 11 people need a medium, and 2 people need a large. No one needs an extra large, but 2 people need a double extra large. And that's the data you've collected. You can then also work out percentage frequencies, which might be important or might be used as part of the analysis. It might be used as an estimate for if this is a certain department in a company, you might then estimate what the whole company needs based on these percentages. So let's do the percentage calculation. The first thing we'll need is our total number of respondents, people that actually entered the survey or gave us their data, and the total here is was meant to be 20, but it's actually 21, which is not nice. So I'm going to change this to a 1. I almost went with 1, but I meant to make it 20 total. Does that make sense? Yep, good, because of my 11 there. And then I can work out my percentage frequencies in my head, but you would obviously have a calculator. So the percentage frequency here is 1 over 20 times 100. That's how we calculate a percentage, and this will come out as 5%. 5 out of 20 times 100. I'll put this in brackets here. This comes out as 25%. This will come out as 55%, 10%, 0%, and 5%. I'll just pop a little percentage sign after all of them, and that's how we calculate our percentage frequency. And of course, our total percentage frequency should be 100%, otherwise we've made a mistake. So there's a frequency table used to represent categorical data, either ordinal or nominal, where you have your categories in order if it's ordinal, nominal, doesn't matter what order, and our frequencies and our percentage frequencies. It's a very similar thing for numerical discrete, so we have to be a little bit careful about how we represent things. So what I'll do now is I'll do the discrete and then we'll come back and do the continuous. So the discrete's going to look like this. Let's set up an example, and the example is going to be number of siblings that people have. But I might do something a little bit outlandish to show you a second example that we might have. So first of all, we'll have our number of, I'll stick with the blue actually, number of siblings, and you're asking, you start with 0, 1, 2 and 3 on your response form because that's what you expect. And then we have our frequency and our percentage frequency. Now when you get your responses though, this happens. You get 3 people that are only childs, and then you get 7 people with 1 sibling, and 8 people with 2 siblings, and then you get 2 people that respond that they've got 3 siblings, but then you get this, 4, 5, 6. This guy down here says he's got 6 siblings. You've got a 0, 0 here. Now, it doesn't make too much difference for how we represent things in our percentages, but it will in a minute. I've made that rookie mistake of making our total 21 now. So I would go through and find our percentage frequencies by doing 3 over 21 times by 100, and 3 over 21 times by 100 is about 14%. I'm going to say 14.28%. You need to really do a better job than me at that. 7 over 21 times by 100, that's going to be equal to 33.33%. And then we get 8 over 21 times by 100 is going to be approximately equal to 38%, so on and so forth. 2 out of 21 times by 100 should be equal to about 10%. And then we get our final 5% down here approximately. So this is 0, 0, but we get 1 out of 21 times by 100. Okay, so there's our final mathematical sums and our percentage frequencies. Now this is something else that you might choose to do. We might choose to, and this is not a great example of this, but we might choose to group our data. So let's say we go 0 to 2, and then 3 to 4, and then 5 to 6, for whatever reason. When we come to graphing, we'll see this a little bit more. And so that would be then a 0 to 2 grouping, a 3 to 4 grouping, and a 5 to 6 grouping. And we'd have a frequency of, we add these up, 18, 2, and 1. Now remember, as soon as you group data, you really need to group data, because as soon as you group data, you lose some of the data. You lose information. So we combine these together. Now we don't know how to split that back up without this information. So try and avoid grouping if you can. But you're going to get questions in an exam situation where you're asked to do certain things. So you might have to group. The main thing to talk about with grouping data is that when you've got your number of siblings groups, you have to make sure that every number that's possible is considered once and only once. Now it's pretty easy with discrete. So if I have 2 siblings, I know which group I go in. I go in this one. Whereas if I have 3, I know I go in here. Now 2.5 is not represented, but that doesn't matter because no one's going to have 2.5 siblings. So it's clear which group I go in, and there's no number that can appear in 2 groups. That's really important. What we're going to do now is to set up a question or a situation for a continuous variable and talk about how we do it with continuous variables. Okay, so I've left this over here just for comparison purposes, but we're now talking about numerical continuous because time is a continuous variable. I'm going to make up some data about this grouping. The problem with continuous variables is we can't just say time 0, 1, 2, 3. Because it's continuous, it's always rounded to get to that 0, 1, 2, 3, so it doesn't make sense for us to have that without having a range. Now of course, there are alternates, and you might see them. You could see something like 0 to 5, it's really common, and then 5 to 10, and then 10 to 15, and then 15 to 20. But I would actually say to you, they're wrong. And I say they're wrong because where does 5 go in the blue one? Does 5 go here, or does it go here? And we have, so you'll see plenty of representations. Have a look at them and analyse them and think to yourself, does that make sense? Is every possible number have a position it can go into? Obviously 21 doesn't, but 21 is outside the range of the data set. But every number within the range, and are any of them double counted? And 5 could go in 2 places, 10 could, 15 could. So I don't think they're really a correct representation. Whereas here I've used inequality signs, which I think is the nicest way to do it, to say that t, time, is greater than or equal to 0, but less than 5. So 5 doesn't go in this category because it's less than. Whereas greater than equal to 5 here means that 5 would go into this one. Or maybe you'll use the less than there and equal to, and you'll have 5 go into this one. You can decide, but ultimately you can then ensure that it fits only in one. So these blue ones, I really don't think they're very good. But I'll leave that for you to consider. Now, we'd set up a frequency and a percentage frequency again. That's the hard bit. This is actually the easiest bit. So imagine we've got 1, 15, what am I going to do here? 8 and 1. So you usually get it somewhere centered around the middle, but we'll talk about that distribution kind of stuff a little bit later. And of course the percentage frequency will be, the total here is 25, 1 over 25 times 100, which is 4%, 15 over 25 times 100, which is 60%, and then of course we get 8 over 25 times 100, which is 32%, and then we get 4% again at the bottom here. You can do those calculations yourself. So when we've got our data and we've decided what type of data it is, we can also collect that data in a frequency table, and we can consider percentage frequencies as well. You just need to be careful about how you capture your data. So there's some really important points embedded in this video about how we collect data and how we set our domains for that data collection. It would be worth taking some notes now to make sure that you remember all this. See you next time.